Bismillahirrahmanirrahim. Today we will discuss a type of optical isomerism, which is the enantiomerism. The enantiomers are the isomers which are non-superimposable mirror images to each other. They are chiral molecules. Remember that the word chiral has its origin from the Greek chir, which means handedness, because enantiomers are like two hands. They looks identical, but actually they are different, as you have observed that a glove of right hand cannot be fitted in the left hand. Both hands are thus the mirror images of each other, as you see in this diagram. The right hand is a mirror image of left hand, and they are non-superimposable. If we try to uh, cover each hand by the second hand, uh, you see that it will not cover. Here is a animation which shows that how chiral molecules or the mirror images are different from each other. You see that here is a molecule which is surrounded by four different molecules. So this is a chiral center of this molecule, and four different groups are shown in different colors. If we place a mirror in front of this molecule, you will have an image like this. And on rotating, imagine a rotation, or take a 3D molecule, you will observe that when we rotate this molecule, it is not like the original one. So they are not identical. In the same way, if we take an example of chlorobutane, there are two possible isomers of this compound. Obviously, we are talking about the optical isomers. You can see in through two-dimensional image, this carbon is a chiral carbon which is surrounded by four different groups. One side has the hydrogen in yellow color, the second side has a chlorine with red, the methyl group in green, and blue group and ethyl group in blue. Same is the case with this one, but you see that both are mirror images of each other. If we try to see this in three-dimensional ball and stick models, you see that the hydrogen with yellow color, as seen in the two-dimension, is in front side of the screen, and the methyl is at backward side. Similarly, in this case, when you rotate the hydrogen at backside like this one, you will observe that in this case both are mirror images of each other. The hydrogen is at backward side in both cases. The methyl, you see that looks like a mirror image in both cases. This one, the chlorine at left side, and here it is on right side. Both the molecules are mirror images of each other. And this part of the molecule, which is the carbon, is a chiral carbon, or previously it is called asymmetric carbon. This is R2 chlorobutane, and this one is the S2 chlorobutane. For further study of the nomenclature of such isomers, please consult to my previous lecture in which we discussed about the nomenclature of these isomers. S brings anti-clockwise rotation from highest priority to lowest priority, and R in clockwise direction from highest priority to lowest priority molecule. And I have discussed it in detail in the previous lectures. So now come to our today's topic, which is enantiomers. You may have heard about the ephedrine. There are two possible isomers of the ephedrine. You can see this ephedrine, the two isomers in two-dimensional diagrams as well as in 3D models. You see that phenyl is at backside in both cases, OH at left side, and in this case OH is at right side. Similarly, the amino chain of the compound at right side, and this is at both are mirror images of each other. If we try to rotate the 3D molecules like this diagram, phenyl group is at backside, so rotate it in a manner that phenyl group comes to backside, and in this case let it be zoom a little while so it is more clear. Again the phenyl group is at backside. You see that both these are mirror images of each other. Here two carbons which are mentioned in green colors in two-dimensional diagrams and in 3D diagrams, ball and stick models of this 3D. Both are chiral center of the molecule, the green colored carbons. they are chiral. You see that phenyl, hydrogen, hydroxyl, and this chain. Hydrogen, methyl, this side of the chain and this chain. So both these carbon are the chiral carbon. One of the carbon is 1 and second carbon is the 2. This one is the carbon number 1 containing these groups, and this one is the carbon number 2. So both these are mirror images of each other. You can see very clearly in 3D models that they are mirror images of each other. One of them rotates the plane of polarized light in anti-clockwise direction, which is negative ephedrine, and second rotates in clockwise direction, so it is plus ephedrine. So these are also enantiomers, which are mirror images of each other. Similarly, we have a compound called pseudoephedrine. There is a little difference between ephedrine and pseudoephedrine. We have seen that both hydroxyl group and this amino chain of the molecule, they are on the same side, but in pseudoephedrine both are on different sides. One of them is the right side and second one is that left side of the molecule. Again, there are two optical isomers of the compound, the negative pseudoephedrine and positive pseudoephedrine. The 3D molecules of the compound. Let it be arranged like two-dimensional, where the phenyl group is at back side of the molecule. You see that in this case. And in the second case, a clear difference lies. Both are mirror images of each other. Again, so they are enantiomers. It means that enantiomers are always mirror images of each other, whether they contain one or two or more asymmetric or chiral carbon atoms. The comparison can be made by using these two-dimensional diagrams. A very interesting character in ephedrine and pseudoephedrine is that they are physiologically active compounds. It means that they affect the physiology of our body, and they have a certain action on our certain systems. The 1R2S negative ephedrine is a central nervous system stimulant and is used to treat breathing problems as a bronchodilator, nasal congestion, orthostatic hypotension, or simply low blood pressure problems, or myasthenia gravis, a condition which causes abnormal weakness of certain muscles. They act as a bronchodilator, and for this reason they are used in cough preparations. You see that I am talking about the physiological activities of 1S, 2S negative ephedrine. 1R, 2S negative ephedrine. This one is the negative ephedrine. 1R2S stereoisomer. While the positive ephedrine, which is a mirror image of this compound, has totally different physiological characters on our body. This is interesting to know that the positive ephedrine is toxic for humans beside some other characters. Similarly, if we talk about the pseudoephedrine, again there is an interesting action. The positive pseudoephedrine, which is 1s2s molecule, has same actions like negative ephedrine. Negative ephedrine and positive pseudoephedrine both have same actions, but action of plus pseudoephedrine is considerably lesser than the negative ephedrine. It means that plus pseudoephedrine is have a little mild action on our physiology as compared to negative ephedrine. And again, the negative pseudoephedrine is toxic. Very interesting. This is the negative pseudoephedrine. This has a toxic action on our body, and plus pseudoephedrine is a respiratory system drug and is a bronchodilator. Now take a simple example in order to understand the topic. We take 2-chlorobutane. You see that 2-chlorobutane, this is the example of R isomer, and this one is the S isomer of the 2-chlorobutane. Again, both are mirror images of each other. Very clear from the diagram. This one is the chiral carbon of the molecule. I highlight it by pressing the button, and you see that the chiral center is now in red color. Both are mirror images. This one is the R and this one is the S. We have observed that there may be more than one chirality center. For example, in this case, you see that there are two chiral carbons in this compound. Methyl are at back side if you turn according to the diagram. This position brings the methyl at back side, and in this molecule this is the case. Both are mirror images of each other. It doesn't seem this upper side is a mirror image, but the lower case is not the mirror image. Both are different in mirror character. You see in two-dimensional diagram, the bromine and chlorine both are on one side, and here bromine is at the opposite side to this molecule, but the chlorine is on the same right side. So this part of the molecule is not showing the mirror image character of the molecules. So it means that the molecules, there may be molecules which have more than one chiral centers, and they are not the mirror images of each other. Remember, such types are called diastereomers. They are not the enantiomers. The main difference between enantiomers and diastereomers is that the diastereomers are not mirror images of each other. As we have seen here in the example, again there are two chiral carbons in pseudoephedrine as well as in ephedrine, but they are, in all respect, they are mirror images of each other. So they are, both these are enantiomers of each other. They are not diastereomers. And in the case when they are not mirror images, then they are called diastereomers rather than enantiomers. The enantiomers exhibit identical physical behavior except for rotating the plane of polarized light. Enantiomers are same in the characters, especially in the physical characters and even in the chemical characters. But if the reagent is chiral, which is being treated to them, then they show different characters. And that is why in our body the amino acids, nucleosides, carbohydrates and phospholipids, all of these are chiral molecules. So enantiomeric form of all these have no such actions if they are not chiral. The enantiomers of a drug that we use for a specific disease has an effect on our receptors, and it has its other enantiomers will be totally inactive due to different reagent. And remember, first of all, this character was observed in thalidomide, a drug which was once used for the morning sickness in pregnant women. Its S-thalidomide is sedative in action, and it causes nervousness to bring down the nervousness, while the R-thalidomide is teratogen. It means that it causes birth defect. Both have totally different actions. Similarly, we have seen this phenomena in ephedrine and pseudoephedrine. We have seen that one of the isomers in ephedrine series is toxic, and second one we use in our preparations of respiratory system as a bronchodilator. This is because the drug enzyme action may have totally different actions, because the receptors in our body, you see that here B, A and C have same connectivity in the receptor and in the drug that we are using, while its enantiomeric form, second, which is the mirror image of the compound, B is on the same side, but A and C are different. So there is a problem in bonding this C on A and this on uh, this site of the receptor. So bonding will be weak and its action will be 0 as compared to this one. Similarly, you may have seen two compounds, the mint and the cumin. We have preparations, spearmint oil from the mint and caraway oil from the cumin. Both these have the compound caravone. One of the isomers is the compound is isopropyl 2-methyl cyclohex 2-ene 1-one. Isopropyl 2-methyl cyclohex 2-ene 1-one. But one of the enantiomer is of S series and second is of R series. You see the diagram, two-dimensional or three-dimensional. This one is the center in both the molecules isomers, which causes different in their optical activity. This carbon is the chiral center of the molecule, this one, in both the enantiomers. The spearmint oil has this type of structure, while caraway oil, its mirror image, has this type of structure. You see that the hydrogen is on back side at chiral center. I rotate it to bring the hydrogen at back side. Of the molecule. And this one, hydrogen is at back side. You see that both are mirror images of each other. If there is a problem, you can consult into two-dimensional diagram, which make it easy for you to understand. Now think that the structure of both the molecules is almost same except for their optical action. This R series compound, we have to represent this R in capital form, as this S is in capital form. So now this R is in capital and it's in standard form. So this compound is present in spearmint oil and this one is in caraway oil. So, and the sensation of both is totally different. There is a great difference between the mint and cumin seeds, and is due to the only action of this chiral center of the molecule. A little difference and the molecule is totally different sensation because it has a different receptor system in our body. Hope you have a good understanding what are the enantiomers, how they are different. We have talked a little difference between enantiomers and diastereomers too in this lecture, and the diastereomerism will be our separate topic. We will discuss the diastereomerism in detail in our coming lecture. Till our next lecture. Take care and goodbye. Thank you.